Alright, in section 3.7, we're dealing with equations of lines in the coordinate plane. Okay, this chapter has been all about lines, usually parallel lines. Okay, we'll look at what parallel lines in the coordinate plane look like in the next section. Our objective for 3.7, though, is to graph and write linear equations. First thing we're going to need for our linear equations, or equations of a line, is the slope. Basically, its steepness. We're going to say the slope of a line is the ratio of the vertical change, the rise, and the horizontal change, the run, between any 2 points. Okay, so my rise and run is going to determine my steepness, and we'll say the slope is its ratio, rise over run. We'll usually abbreviate it with an m. And if a line contains the points x1, y1, and x2, y2, then m is, given by this formula, y2 minus y1 over x2 minus x1. In other words, the difference in the y coordinates, okay, the rise, over the difference in the x coordinates, the run, between any 2 points. Alright, so in problem 1, let's look at finding the slope of a line. Part A, find the slope of line A here. Okay, so it looks like we have line A. And for the slope, I could use any point, set of points on this line. We'll use the ones where they give us the number. Okay, m is equal to, we said the rise, so the change in the y's. Now, like usual, it doesn't matter which point we say is our x1, y1, and which one's our x2, y2. I'll just start with the bigger numbers to keep things positive. So we'll go y minus y, 7 minus 3. Over in the same order then, x minus x, so 5 minus 2. Okay, which will be equal to a 4 over 3. Okay, so we'd say our slope for this line is 4/3, meaning that if I start with any point on the line, we'll use this one for example, I'll have to go up 4 for a rise of 4, 1, 2, 3, 4, and right 3, 1, 2, 3, okay, to get to that next point. Okay, part B is the same idea. Why don't you pause the video, take a minute to work through that one, and then hit play to check your answer. Now in parts C and D, we have a couple of special cases of slope. C, find the slope of line C. Notice this line doesn't have any slope. It's flat. It's straight horizontal. Okay, we'll always say a line that's horizontal has a slope of 0. And the reason for that is if we go calculate our slope, y minus y, we'll go 7 minus 7. Okay, over x minus x, so 1 minus 5. That's equal to 0 over negative 4, we could say. And 0 divided by anything is just a 0. Okay, so we can tell that point's horizontal, or that line's horizontal, we know it's always going to have a 0 slope. Okay, in part D we have kind of the opposite issue. D is going to be a vertical line. Okay, we're going to say it has a slope that's undefined. And the reason for that is when I go to calculate the slope, again we'll go y minus y, so I can say negative 2 minus 0 over the run x minus x, so 4 minus 4. That'd be equal to a negative 2 over 0. Okay, we've been saying since 4th grade can't divide by 0, okay, not a real number. That's why we'd say this slope is undefined. Okay, kind of like an infinite slope. Okay, so if we're finding slope, there's always going to be 4 cases we can pick from. A positive slope going up from left to right, negative slope going down from left to right, and then a 0 slope for a horizontal line, or an undefined slope for a vertical line. Once we have the slope, we can look at writing the actual linear equations, and we'll look at 2 different ways to do that, 2 different forms of a linear equation. First one's the slope-intercept form. Okay, that's an equation of a non-vertical line that's y equals mx plus b, where m is the slope and b is the y-intercept. Okay, again, y equals mx plus b, M's our slope we learned how to find a second ago, and B is going to be the y-intercept where the graph crosses the y-axis. Okay, we also have the point-slope form. That's going to be an equation of a non-vertical line with this y minus y1 equals m times x minus x1, where m again is the slope and x1, y1 is a point on the line. Okay, so again we have y minus the y coordinate of any point on that line is equal to m, the slope, times parenthesis x minus an x coordinate from that same point. Right, so let's look at using those equations. Problem 2, part A just says graph y equals 2/3 x plus 1. Okay, here we're given an equation in slope-intercept form where I know my slope, my m is equal to 2/3. That's just the number in front of the x. And we also know the y-intercept, which is just a 1. Okay, to graph this equation then, we'll start off with our y-intercept, the 1, and then from there we'll just follow our slope. Slope is 2/3, meaning we'll go up 2 for a rise and right 3 for the run. Okay, so up 2, right 3. And then to finish my line going the other direction, we can do the opposite. This time we'll go down 2, left 3, and down 2 again, left 3 more. All right, connect your dots. Don't forget to put arrows on the end. And there's the graph of this line. Okay, part B is the same idea. Push pause, give graphing it a shot, and then hit play to check your answer. We can also graph lines using the point-slope form of the equation. Okay, because again, when we're given a line in point-slope form, we know the slope, which is just this number in front of the x, the -2. We can think of that as a -2/1. Okay, so rise of down 2, run of 1. And then what we also have in the point-slope form is we're given a point on this equation. Okay, we have y minus 3. That's going to be the negative of the y coordinate, which would just be a 3. And then for the x plus 3, that's going to be a -3. Remember, things switch signs as we go from the actual point to the equation because we have the y minus y1, x minus x1. Okay, so here we'll start at -3, 3 for our first point. We'll follow that slope along, down 2, right 1. Okay, down 2, right 1, down 2, right 1. And then we can do one more point, left 2, up 1, doing the opposite as we go to the left. And then connect the dots for our line. Okay, part D is the same idea, graphing a line in point-slope form. Again, pause the video, work through the problem, hit play to check your answer. In problem 3, we're going to be writing equations of lines. Part A asks, what is the equation of a line with slope 3 and y-intercept -5? Okay, we have the slope and the y-intercept. I'd say we want to use our y equals mx plus b, our slope-intercept form of the equation for this one. Okay, so filling those parts in, y equals m, which is our slope 3. Okay, x plus b, the y-intercept's a -5, so we'll just say -5. Right, in part B, same idea. This time instead of a y-intercept, we're giving a point on that line along with the slope. Okay, so point-slope. This time we want to use our point-slope form of the equation our y minus y1 is equal to m times x minus x1. And again, just filling things in, our slope's 2. Then we'll go y minus the y coordinate, so minus 5. And again, we switch signs as we go from point to equation. Okay, is equal to 2 times parenthesis x minus the x coordinate minus negative 1, in other words, plus a 1. All right, part C and D is the same idea. Hit pause again, work through the problem, and then hit play to check your answer. In our next problem, we're going to look at using 2 points to write an equation. Part A asks, what's the equation of a line at the right in slope-intercept form? Okay, so I have 2 points on my line. I'm not given the y-intercept of this line, so we're going to have to figure that out. We can start off with the slope. Okay, so back to our first problem. We'll go y minus y, so negative 4 minus negative 1, in other words, plus 1. Okay, over in the same order, x minus x, so we'll go 1 minus 2. That's going to give us a negative 3 over negative 1, which is equal to just a positive 3. All right, so now since I don't have the y-intercept, I can't start this problem off with slope-intercept form. We have to use one of these 2 points for our point-slope form. I'm going to use the 2, negative 1 because it has slightly smaller numbers than the other point. Okay, so filling things in, we can say y minus the y coordinate, so y plus 1, is equal to the slope 3 times x minus the x coordinate, x minus 2. And then notice for this problem we want an answer in slope-intercept form though. So to do that, what I'll do is just solve this equation for y. We'll start by distributing the 3 on the right side. That'll give us y plus 1 is equal to 3x minus 6. And then subtract 1 from both sides. That'll give us y is equal to 3x minus 7. Okay, so obviously could have done this problem without a graph, but looks like it makes sense. Our y-intercept would be down here somewhere like negative 7. It's up 3 over 1 from point to point. Okay, so it looks like we got this one right. Okay, part B is the same idea. Pause the video, work through that one, and then hit play to check your answer. All right, last set of problems we're going to look at are writing equations of horizontal and vertical lines. Part A, what are the equations for the horizontal and vertical lines through the point 2, 4? Okay, let's sketch out what that's going to look like here. I'm not going to make a detailed graph, I'm just going to put in the kind of overall shape of it. So we have a point here, 2, 4, it's going to look something like that. First off, for a horizontal line, that's going to be a line running straight left to right, okay, through that point. Now we said horizontal lines have zeros for slopes. So as far as the y equals mx plus b part, our m would just be 0. So for this equation, for the horizontal line, I can just say I have y equals 4. It's just taking the y coordinate from that point. Okay, vertical lines can be simple as well. We said vertical lines have an undefined slope. Okay, so we can't think of in terms of y equals mx plus b, but I can think in terms of my x-intercept. In this case, my x-intercept is just a 2. So we can write a similar formula for our vertical line. We won't say anything about the y, but we'll say for this vertical line, our x is always equal to 2. Okay, horizontal lines will have y equals equations. For vertical lines, we'll have x equals equations. Okay, one more time, pause the video, work through part B, and then hit play to check your answer.